Alright, today's video is on a bug fix to QSpectrumAnalyzer, which is a piece of code which allows you to view a wider span of the frequency spectrum than your SDR radio ordinarily would support. I'm using a HackRF in this case, which supports a 20 megahertz maximum span. And we're looking here at from 2.4 gigahertz to 2.5 gigahertz, so we're looking at 100 megahertz of span in this case. And the way that QSpectrumAnalyzer does that is by using a HackRF sweep function in this case. But in any event, it just takes portions of the spectrum, in this case 20 megahertz at a time, sweeps through the full range specified in 1 second, and then gathers that data and presents it all in this graphic representation. The bug is that the waterfall diagram, which is supposed to be shown down here, is not working. And the reason for that is shown here when you launch QSpectrumAnalyzer. There's a problem in plot.py code on line 317. Too many arguments specified to the scale function call. And there's been a change to the PyQt graph library that's being called here. And so I'll show you the problematic line. This is the problem line right here in 317, and then the bug fix, which is right below it. So what I'm going to do is comment out this line, the bug, and uncomment the fix, and then we'll go back and we'll stop QSpectrumAnalyzer, and then we'll just relaunch it. Now it's launching with the corrected code, and once again I'll start it. And so there you go, there you see the waterfall. And what's cool about this is that it's sweeping the spectrum here, 100 megahertz, every second. And this yellow line here is actually a signal that I'm outputting from my Tiny SA Ultra. And what I can do is modify that by just bumping the frequency up. So I'm going to bump it up, and you can see it moving as I change the frequency. There you go. So I'm just going to change that to 2.47 gigahertz, 2.47 gigahertz. And there you go. Within a second, it's moved over there to the right. Let me move it back to 2.42 gigahertz, 2.42 gigahertz. And in 1 second, it's swept that 100 megahertz of span and updated the data. So it's a pretty neat little program that allows you to extend what you can see in the spectrum. So the fix, once again, is pretty straightforward. It's just 5 lines of code. I will paste the bug and the fix below the video so you can have a look at that, and just copy and paste it into your own version of the code. Alright, that was the point of this video. I made an earlier video which had a simpler fix, which actually had some problems with the scaling within the waterfall diagram, so this is a better fix. I've taken that other video down. Anyway, thank you for watching.